Okay, the next talk is from Paul Louis and Raed, and it's from Mongolia. They're from Mongolia, and they will talk more about multimodal data and multimodal search use cases. So I'm super excited.
Likewise. Thanks, everyone. So today we're going to be talking about semantic image retrieval. We're going to see a bunch of use cases, what works, what is kind of complicated, and where it fails completely. My name is Raed. I'm a software engineer, mainly working on the front-end end of things at Algolia. And my colleague here is...
I'm Paul Louis. I'm working as a machine learning engineer at Algolia on image search and now GenAI things.
So let's start by a little agenda. So we're going to see what works, what is complicated, and where it's kind of gets stuck. So we want to talk about visual items, but the entire conference has been talking about semantic, text, etc., etc. But our world is super visual, and we see this world through screens. So the web is also visual by implication. Some actors understood this reality like a really long time ago and have been present there. So we can see, for example, that Pinterest, basically, they say that 97% of their searches there are M-branded because people come to shop or to browse generic things and not specific brands. Airbnb have identified that places with professional-looking photos will have up to 20% more bookings, and they even offer some services to help you get your apartment professionally photographed. And Netflix have done a study, and they identified that 80% of the browsing experience on Netflix is mainly focused on the thumbnails and the quality of the thumbnails. So sources there for all the studies that they have done. And so we can see that images are a pretty big deal. Famously, ITSE did a hackathon where they allow you to take a picture of an item that you have at your place and find similarly looking items in their inventory that you can buy. And they invite you to read this really good blog post about how they did it and how it works. And it's a great UX. But what happens if you don't have that item already at your home? Pinterest kind of tried to solve this problem by shopping through visual pins. So if you see a picture you like, you can click on a pin, and there you can find like the rug or something that looks very close to it. These are huge marketplaces. So how do we do the playing field? Like, how do we level it to reach what they do? And to do that, Paul is going to talk about what you have been working on at Algolia.
Indeed. It's been, what, a year and a half now that I'm working on this model. And I would say that no, you can have it too. We've been building a semantic image recommendation API that analyzes the images in your catalog so that you can provide semantic image recommendations based on it. So that given one image in your catalog, you can suggest other items that have the same vibe. This allows you to power quite advanced visual user experiences. You can replace items that are out of stock by something similar. You can look at your cart items and suggest something that would go well with it. There's many ways to implement that. But before talking about the use cases, I'd like you to have an idea of what this system actually is like. So under the hood, we are using vectors and metadata together. There was a great talk at Haystack US a few weeks ago by John Solitario from Rockset saying that all great vector user experience is hybrid-based. And I would agree with that. We've been building this system using image vectors. So at the core, it is just like Clip. Right now, we're using ResNet. There is another talk about how trying Clip didn't really improve on some benchmarks. So we're sticking with ResNet, ImageNet classes, train model for now. But we take these vectors and we are going to hash them for scaling. If you tried playing with ResNet vectors, it works great for catalogs of a few thousand items. Our customers have millions of items, so we need to find a solution. The solution we're working with so far is learn semantic hashing. This is something you can find more info. You'll see at the end of this slide a link to another talk. But in a nutshell, we take the vectors, we hash them. Once they're hashed, we're going to put them in a system that allows retrieval. And this we're going to do with approximate nearest neighbors so that it is fast. We use hierarchical, navigable, small word as a representation that gives you quickly the nearest neighbors based on a given point. But once you have a set of nearest neighbors, it doesn't necessarily make a good user experience or a good product for your users. So we mix this with metadata using object-level metadata filtering so that you can show things that are available in stock or in your users' favorite colors, for example. Finally, we know that you might be building more or less advanced user experience. So we want you to be able to use rules so that you can boost and bury specific items based on whatever is hot currently in your business. Again, this is really a nutshell of the system. There's a link at the bottom to the slides of a talk I gave in ECI Air last year, where I go in depth into each of these parts of the system. But today we want to talk to you about user experience. And we mentioned it. There's great use cases, there are challenging ones, and there are those that just are a bad idea. I'm going to start with the easy way, the good. We've heard this morning about golden data sets, golden data, golden everything. I hope that with all of this gold, you're going to make a little geld. And hopefully, if you get some money on the side from this jig, you might want some nice home decoration. We have a customer called xtdeco.aero, and I don't speak Romanian, but I really like their products because you can buy lamps that are gold-plated animals for your house. Don't judge, it's quite nice, I think. And I wanted to check what our model would see when looking at an item like this. They sell thousands of decorative items, but the top 3 results that we retrieve are, I would say, quite relevant. It's not an ostrich anymore, but those are also gold-plated animals holding more or less lamp bulbs in their hands or their beaks. And remember here, this has no textual metadata. The model sees only pixels, or rather vectorized representation of the pixels, and yet is able to make some sense out of more or less noisy, more or less surprising items. Another example I saw in xtdeco, which made me happy, is this rabbit in a hat, or rather lamp with an abat-jour hiding the rabbit. And if you worked with computer vision, you know that obstructed objects are really challenging because what the model was used to see is not usable anymore here. Maybe the nose of the rabbit cannot be used. So it was a pleasant result to see that the top recommendations, or the forte asseminatore, as they say, are also other animals lamp with obstructed elements. I think it shows the strength of a generic model like this, which will be able to do its best given whatever data you send at him. And to give you an idea why it works here, you have to understand what the model sees. So when we're looking at something like this, an ostrich, the model doesn't really see pixels. The model sees classes. It's been trained on ImageNet classes, which, if you check the data set, has really random images. For example, top left, you see examples of the goldfish class. Top row is quite easy samples. I would say that's a fish. Bottom row on the left, is that a microscope? Is it blood cells? What is it? The model still learns to realize that this is a goldfish. And that's what helps it make some signal out of the noise. And in the case of our obstructed rabbits, I think ResNet classes give it a good ability to recognize and make some sense. And it generalizes. We can share with you a demo we made with 50,000 artworks where the model learns to recognize Picasso from Picasso and Gebonsky from Gebonsky. It's amazing to me that a model trained to separate apples and oranges is able to learn the difference between impressionist and postmodern painting. And indeed, on xtdeco.aero, it doesn't do good only on the animal lamps items. We saw they have some wall decorative panels. You can buy them 1 square meter at a time and change the decoration of your house with it. And so if you look at these square cubes, there's not much metadata. There's nothing in the title. But the recommendations with a face are other decorative panels made out of 3D white elements that you could use if you don't like the squares, but would rather something a little round. So that works in the abstract, but it's also useful in concrete cases.
Indeed, thanks. So a more concrete case is something pretty relatable. You pull on your kitchen cabinet and for some weird reason it breaks. So now you have 2 options. Either replace everything so it matches, or you end up with one ugly kitchen cabinet that doesn't match the rest, and my OCD will not allow that. So what to do? We have here a great example with cabinet parts. And where you go looking for a kitchen cabinet handle, you can start describing what you're looking for, like the color, the size, maybe the shape. And here, in this case, I found something that almost fits my need, but not exactly. I need something a little flatter. I need something a little less wide. And I lack the technical knowledge or like the technical language even to describe what I'm looking for, if it was even labeled correctly. So thanks to image similarity, what I can do is here they have shop similar style product, and I can quickly browse through their inventory by looking similar. And I can see that this is the item that I was looking for. So I can save a fortune on replacing my entire kitchen, and I can find the item that suits my need. But they have also great implementation that I would love to highlight, which is variant awareness. So for example, here they use deduplication for the same product. So here it's in an antique bronze, but we can switch the color, and it's Italian nickel, and the color will also change for the best image recommendation around there. And it would surface things that would not have been surfaced maybe with a regular system. For example, from the nickel cabinet knob, you can find a natural bronze one. They look similar, but maybe I wouldn't have found it otherwise. Another great example about color, and Paul Louis has great color styling, is textiles. So for example, if you are pro textile like user like Paul Louis, you would recognize that by looking at the blue flower pattern, you can have great matching patterns in like purple or green. But what happens when your user is not as good as Paul Louis and they're just come to your shop for the first time? Here we can surface interesting tissu associé where we can go from imprimé fleur to something more abstract that your average user would not have thought of initially. So now that we have saw some great working use cases that are actually in production, let's see what works a little less. So the bad. Would you, as a user, like book your next Airbnb just based on the image look? Or would you buy an instrument just based on how it looks without trying it? Or would you buy your next shoes just for the fashion? I wouldn't recommend it, like comfy shoes are good. How about building your next Pokemon set? Would you build it just because it looks nice and shiny, or would you look at the stats? The problem with these cases is they're not bad. They're usually awfully badly implemented. So in some cases, it works well if you have visual signals to alongside your other signals, like the category, price ranges, availability, both in size and geography. Great example happened recently. So we were looking at hotel rooms to stay in Berlin, and we found something that looks really nice with an office to continue working on these slides, but it was not available. So the nearest neighbor also looked really good, and we wanted to book it. However, yeah, that's quite the lack of commute. So instead of doing that, we should probably leverage other signals such as geography, distance, price into our criteria. So it's not bad per se, but badly implemented. And we can add these criteria to your next search query. So for your Airbnb, probably location makes sense. For your guitar, price range, style, maybe tonality. For your shoes, brand, comfort, size, and you for Pokemon, like your attack and defense stats. Another great example of visual similarities being a good signal, but not enough alone, is this Danish guitar store. And I would not be able to pronounce the Andre Copte Costa. If you speak Danish, you can insult me later. And here, if I'm looking at this guitar, I can see items that are related, such as cables, ukulele, things like that. But what happens for this new item that's in the inventory, which is a mandolin, where it doesn't have enough events? So you have like a kind of cold start problem from your inventory. I mean, it's an expensive guitar. I wouldn't buy it just immediately. I would need to look around. So here, a mandolin, so here a mandolin looks a lot like a guitar. So I can recommend mandolin, but I can also recommend visually similar items that would be interesting. It's a great use case for suggesting things when you don't have enough events yet. And you avoid the blank page problem by having always something to show to the user. This is an internal use case or test we did. So if you are looking for some Nike Air Max 97 shoes, so it's kind of pretty specific, you're pretty much going to be interested in that kind of like look. And this signal gives you specificity. It gives you the intent. So you know you can tailor your experience around this kind of shoes. But what if the signal is like more relaxed? By looking at these pastel color Reebok, I can probably suggest also New Balances that look kind of the same. Another great example is La Redoute. PS, they're not using our system, but it was so good I had to show you. They're French, they have been around for like 200 years, so they kind of know what they're doing. And here they give you a way to explore alternative items in context. So when you're looking at the picture, you can say, oh, I don't like it. I have the button immediately to see something similar, but slightly different. Another idea is if you don't have the size. So you can pick basically other articles just because you don't have the size. And they also do this awesome thing where you can explore similarly looking items in place while keeping this kind of shop the look source item there. So you can display the original item, and then you can filter in stock and in the size that I want. But also, they allow me to sort by similarity score, but also other things such as pricing. Now we've seen what works and what kind of needs some implementation. Well, we were going to talk about what doesn't.
Yes, because you've seen some use cases like this are great if you implement them the right way. But let's be honest, friends. I know you came at this talk to see also the really bad cases, the ones that cannot be saved, the ones that are simply ugly. Some use cases are not a good fit. But this is the last talk before lunch. Who's hungry right now? I am sorry for you all, because the first ugly use case is random user review pictures. I've been playing with the dataset. I think it's Yelp or a similar one. They have like 70,000 restaurants, bars, places with metadata and user pictures. I was dying for datasets with user pictures that I could try to see user-generated content with our model. And I mean, this is decent. Out of Caveman Kitchen, blurry pic of a pizza, you get blurry donuts and blurry burgers. I think not so bad, quite decent. Even on the sweet stuff, it works too. Chez Alice Bakery brings you to a sweet acorn and ice cream. This is good. Man, I'm getting hungry. Let's move on. Random user pictures again. I mean, people put anything in a Yelp review. So you'll see images of the food. You'll see images of the waiter. Heck, you'll see blurry storefronts. What looks like Firestone Grill? Well, Five Guys, I guess. Probably not a very good use case. I mean, it gets worse. In the same dataset, you also have moody ambience, darkly lit shot of the bars. So, okay, Broadway Brew Biergarten looks a lot like Fred's Italian Corner restaurant. That is like a blurry, dark inside room. Sometimes the only thing in common I could find in the top results, 70 is quite a good score. The only thing in common between this whiskey bar and this Thai restaurant is that the decoration on the walls are red. I don't think this is very relevant. And again, we're matching food pictures. That's great, but I'm hungry again. Let's change use cases. You remember these memes where AI was bad at hands, like AI accepting the job? Yeah, sure, why not? Well, our AI model also had this kind of a fixation with hands. We saw this, and that's internal use case, a customer sending us a support ticket saying, why actually, when I'm looking at the terracotta pot, you're recommending mittens and gloves? I looked at the data to understand. On paper, it seemed very weird, but when I look at the pictures, I get it. I mean, this is a shot of a hand. This is a shot of two hands. 68 score, quite relevant. This is a lesson that you might have state-of-the-art models, but garbage in, garbage out. If in the end, you're giving it some very low signal, you cannot expect to have a good results on that. So what could you do in such a use case? We said they cannot be salvaged. I think you can still try a few things. First, obviously, try metadata. This is the elephant in the room. But if Airbnb is shipping professional photographers to your house, probably it's for a good reason. And if you want to, if you invest in your inventory, if you invest in your merchandising, you should also invest in good product shots. But that's not the only thing we can do. And as product builders, we should try to do our best with the data you send us. So we can try to focus the imagery a bit better. We can try object segmentation, maybe by recognizing forefront and background so that there's a little more resilience. And ultimately, I think in such a use case, you should use our threshold features because we give you the score, but we give you an API that's quite flexible, allowing you to build the experience you want. And in this case, I would argue the experience you want is that. So that can be salvaged to some extent. But ultimately, if the pictures are not a good representation of what your users want, it is unlikely that any of these techniques will help. I saw an example working on an internal customer. They're designing gym and sportswear. They build it in-house. They push it together. They're doing a lot of experimentation. So maybe a designer sketch something. It looks nice. They will do a series with 300 items, see if it sells before investing further. And so sometimes the metadata are a bit sketchy. The picture is made a bit quick. They just want to see if it sells. So here you're looking at a resistance band, something that helps you get strength training. But I would say you're mostly looking at a muscular leg on the side. And so if you have pure muscles in, our model will give you pure muscles out. It's a good image match. It is not a great conversion bringer. So to conclude on the ugly, these use cases could be improved with object segmentation, with category filtering, by using more focused imagery. But until then, when your use case visual signal is not an important purchasing criteria, you should prefer other recommendation models. Maybe you can leverage user behavioral metrics. And if you don't have, you'll enjoy the talk by Stavros and Charlie coming next. Maybe you want to use content-based metadata. Just projecting categories and metadata in a vectorial space can give you decent recommendations to power your basic carousels. So I think that's the conclusion on the bad use cases, but we saved you the best, worst use case for the end. But maybe first, what to do when a use case is ugly? Because I'm the one saying it's ugly. It's still your use case. You deserve to implement it. Maybe you should try something else. There is a better alternative to serve your content. You can try metadata-based carousel, just using the categories that you have, just using, even maybe the description can bring you a long way if you do a projection and find cosine similarities based on the description. Again, you might want, and you mostly want, to use user behavior-based suggestions. If people who like this also like that, if when an item is out of stock, your users end up going to the other one, I think you should start from this before going into the advanced content-based. You can suggest alternative items. You can offer complementary items on the cart. There is a lot that can be done with user behavioral signals. So I hope that you consider it. Ultimately, don't force a square shape into a round hole. Image-based suggestions is only one way to surface relevant items to your users. And if you have a good recommendation platform, you will have a lot of different models to mix and match from. But I told you there was a last bad use case. We had an internal dataset with pictures of our colleagues. So I gave a try. Who do I look like? The results were bad, but you don't know my colleagues. So Raed had the great idea to implement this with more well-known faces. Anyone has an idea who is the closest looking actor to Nicolas Cage in the 10,000 most well-known actors?
Neither did the model.
Neither did the model. According to him, it's Russell Crowe. I mean, 80, that's a high score. So clearly they have something in common, maybe the bird. Another case we saw is, who do you think looks like Scarlett Johansson? These days, we mostly ask who sounds like Scarlett Johansson. But again, according to the model, Abigail Hawke, I don't know her, but okay, they're women, they're blonde. Is that probably the end of the matching? This is the limit of a system trained to recognize ImageNet classes. It has no knowledge of facial features. It is meant to differentiate apples from oranges and not Nicolas Cage from Russell Crowe. probably you should not do that. And finally, because we're French, we got to share with you a very nice use case, go well with the lunch that's upcoming. And it's a customer of us that said, the model is nice, but all of my items in all of my catalogs get a very high score. So it's the same to me. Whatever the item I recommend, it gets a high score. Can you guess based on nationality? It is wine bottles. Nothing looks closer for a ResNet trained ImageNet model. Nothing looks closer to wine bottles than other wine bottles. And if your use case is super specific, image recommendations based on generic classes is just not a good fit. So to conclude?
To conclude real quick, because I have been getting glares from the left, people getting hungry. So good, great use case will get you immediate uplift, but you have to know what you're doing and why you need image-based recommendation. The bad sometimes only means that you need to add additional signals to get the benefits of such system. The ugly is, well, try for some use cases like dating apps with faces or visual similarity is not a predictor of like user satisfaction. So it should be avoided in that. What I can say is think about your use case. What do you need in particular? You can ask yourself these questions. Would image matching immediately delight my users by a great experience? Would it work well with other features and help with the user's purchasing criteria? Or would it ultimately be just a distraction from the journey? Because you can look at these questions and you'll understand what the user wants to see from this experience and have a great one. Thank you for your attention. You can try the stuff here. There's documentation. You can get the slides there. And we have, I think, 40 seconds for questions.
I think we have time for one question. Okay, then.
The people.
Yes, thank you. So what would be the solution, I mean, to be okay with all the use cases, to train another model, or how do you adjust if the model is?
I think the solution is to experiment and iterate. So you want to try small and move from there. You want to first check what are the results internally. If they're good, show it to your users, maybe A/B testing. If they're bad, iterate from there. You want to try to refine maybe the image results first. So if you have any kind of signal that's a predictor of your user interactions, if you know that match in category or the fact that the item is in stock will make a higher chance of conversion, try to blend the image signal or to filter the image recommendations based on this. And if this still doesn't work, don't wait too much before trying another model. And you can try off-the-shelf solution. We have like collaborative filtering based recommendations from what people also about, recommendations based on the content, even just falling back to a search. This is something we haven't mentioned in the talk, but the UI components we provide for recommender models, when you have no results, we offer you to fall back on a search query. You can say, okay, I'm looking at this shirt. There is nothing that looks alike above the threshold that I think makes good results. Let's fall back to having a search in the same category, in the men's clothing, in the same price range. And that shows something good. Like Raed said, have always something to show is probably a good approach in e-commerce.
And thanks a lot for the talk. Thanks again for the talk.